Section 5.2, Part 2. In this section, we are talking about multiplicity, and multiplicity is where you are going to have multiple of the same zeros, and the multiplicity is going to affect the way the graph behaves. If the multiplicity of a zero is even, it is going to cause the graph of the function to bounce at that zero. If the multiplicity of a zero is odd, it is going to cause the graph at that zero to go through the zero. Let's look at our first example. We're given y equals x cubed minus 4x squared plus 4x. The first thing we're going to want to do is factor this. So they all have an x in common. So we factor out an f, and that leaves me with x squared minus 4x plus 4. So now I'm looking for two numbers that multiply to positive 4 that add to negative 4. So minus 2 and minus 2. Bring down the x out in front. Okay, so I can rewrite that as y equals x times x minus 2 quantity squared. Okay, so let's find our zeros now. So set x equal to 0, set x minus 2 equal to 0. So x equals 0 and x equals 2. Okay, well on this factor of x, it has an invisible exponent of 1. So this is going to have a multiplicity of 1, which we don't normally say, but 1 is an odd number, so it's going to go through at that graph. Okay, x minus 2 has the 2 as the exponent, which is going to make this have a multiplicity of 2, which is going to cause my graph to bounce at that instant. So now let's talk about the end behavior so we can continue to sketch our graph. So if you look up here at the very beginning, you started with x cubed. That's an odd and it's positive, so as x goes to negative infinity, f of x goes to negative infinity. And as x goes to positive infinity, f of x goes to positive infinity. Okay, let's also find the y-intercept. To find the y-intercept, you plug in 0 for x. You can either plug it in for 0 or for x in the original function or in the factored one. Either way, you get the exact same answer. So, since I'm multiplying by 0, it gives me a y-intercept of 0, 0. Okay, so now let's start to begin our graph. Okay, so I'm going to graph my zeros first. So at x equals 0, it should be going through. And at x equals 2, it should be bouncing. Okay, the end behavior is down on the left, up on the right. So you go through at 0, and you are going to just touch 2 and bounce back up since it had a multiplicity of 2 at x equals 2. Example 2 is different than example 1 because it's already in factored form. So that means we get to go straight from our factored form to find our zeros. So we set x plus 2 equal to 0, subtract 2, and you get a 0 at negative 2. Set x plus 3 equal to 0, and you get a 0 at x equals negative 3. Now, I know I forgot to do this in our first example. Remember, zeros are points on the graph, so you have to write it as the point negative 2, 0, and the point, it would help if I wrote this problem down right. Okay, it was x minus 3. So to move negative 3 to the other side, you add it. So this would be the point 3, 0. Sorry about that, guys. So then we need to look at their multiplicities. So since x plus 2 has an exponent of 2, that means it has a multiplicity of 2. So at the 0, negative 2, 0, it's going to bounce instead of going through the 0. Okay, x minus 3 also has a multiplicity of 2, which means at the 0, 3, 0, it is also going to bounce instead of go through. Okay, let's find the y-intercept. So to find the y-intercept, we plug in 0 for x, so we get y equals negative 0 plus 2 squared times 0 minus 3 squared. And when you multiply that all together, you get 0, negative 36. Okay, now that's a really large y-intercept, so I might just rough where that is on the graph since it is really big, but I just wanted that to be an extra point for us. Now let's talk about the end behavior. So since it's in factored form, I have to count my exponents to determine the whether it's even or odd. So I have 2 exponents here, 2 exponents here. 2 plus 2 gives me 4. 4 is an even number, so it's an even degree. And then since out in front is a minus sign, it's even and it's negative. So as x goes to negative infinity, f of x goes to negative infinity. And as x goes to positive infinity, f of x goes to negative infinity. So on both sides, they're pointing down. So we're going to graph the zeros, the y-intercept, and the end behavior, and then we're going to sketch the graph. Alright, so we are going to start by graphing the 0, negative 2, 0, and then the 0, 3, 0. Okay, 0, negative 36 is all the way down here, and I'm going to label that as that point since my scale doesn't exactly match. Then as x goes to negative infinity, f of x goes to negative infinity, it's pointing down. And then as x goes to positive infinity, f of x is pointing down. And remember, both of these have multiplicities of 2. So that means instead of going through the 0, it's actually going to bounce. So I'm going to start, I'm going to come up, I'm going to touch the 0, I'm going to come back down. I'm going to go through the y-intercept, I'm going to come up, touch my 0, come back down. And that is a rough idea of what the graph looks like. Now we are going to look at the relatives, minimums, and maximums for each of these graphs. And you're going to need your graphing calculator for this. So if you don't remember how we find the minimum and maximums from before, I'm just going to refresh your memory. So remember, you would go to the y equals button in the top left-hand corner, and you would type in the equation that was given to you. And then I normally press the zoom button, which I believe is right to the right of it, and I do 6 for standard because that changes the window back to negative 10 to 10 and negative 10 to 10. And then if you need to, after that, hit the window button and adjust it yourself, you can. But that way, it always goes back to that basic window. And then to actually find the relative minimums and maximums, you're going to press the second button and then the trace. And depending on whether you're finding a minimum or maximum, you're going to press 3 for minimum. And you're going to press 4 for maximum. So here I've drawn a random graph that you might see on your graphing calculator. And up here, both of these points are going to be relative maximums. Okay, so you're going to have to find them separately. So if you start over here with the graph on the maximum on the left-hand side, you would press second, trace, and then option 4 for maximum. Remember, the left bound is on the left side of the vertex, the right bound is on the right side of the vertex. And then you're going to have to repeat that whole process again. So second, trace, again 4 for maximum. Left bound is on the left side of the maximum, right bound is on the right side. And remember, every time it says guess, you just press the enter button so that it can tell you the answer. Down here at the bottom, this point is considered a relative minimum. And so to find it, you're going to press second, trace, and you'll pick option 3 this time for minimum. again, left bound on the left side of the minimum, right bound on the right side. Guess, just press enter, okay? Using your graphing calculator, you could also find all of your zeros. Okay, remember the zeros are where your graph goes through your x-axis, so you would press second trace and pick the option for the 0. Remember, you start on the furthest left-hand side and you do left bound, enter, right bound, enter, guess, enter. And then when you move to the next one, it would be above and then below. It's always alternating. When you come to the next one, it would be below and then above. And the last one, it would be above and then it would be below. Remember, whenever you get an error, you just have to repeat the process all over again. There's no going back to fix it.